here to talk about, and this is going to be interesting considering what happened this week.
What? Oh, yeah, Next.js.
We'll see. But yes, absolutely. Here to talk about React 18 concurrency and explain is Ivan. Let's go.
Thank you. You saw some spoilers just a minute ago, but hope nobody remembers anything. OK, so 1,489 days. This is how much time passed between Dan Abramov showed the first preview of what back then was called time slicing, and the React 18 release, which finally made these capabilities available for everyone. In these 1,489 days, time slicing went through a bunch of rebrandings, several API changes, and today became known as concurrent rendering. Now, my question to you folks, who here works or has already worked with React 18 in production? Oh, nice. What about React 17? 16? Has anyone used React 19? No people with the time machine, OK. How many people don't use React here? All right. So, well, is saying you may leave root? No. OK, yeah, probably yes. No, don't leave. Don't leave, actually. OK, so you'll probably find something interesting, too. Anyway, so if you upgraded to React 18, you might have already seen its new features. If you haven't, maybe you've heard about concurrent render on Twitter, or maybe, like, again, if you haven't, maybe this name sounds familiar to you, or maybe it sounds scary, but that's OK. What's actually new in performance-wise in React 18 is just 3 things. The new hooks, like useTransition and useDeferredValue, some hydration improvements around Suspense, and better batching of updates, like useState and useReducer updates. And working with these things, if you have worked with React before, if you haven't worked with React before, especially stuff like useTransition, might sometimes feel like magic. You would see it a tiny bit later. So today, I want to show you what actually happens in the app whenever you use the first and the second performance features, which, by the way, are called together the concurrent features, how React makes this work under the hood, and what are the drawbacks. And so let's start with the useTransition, useDeferredValue hooks. And to show them, let's dive into a slow app. So here I have a basic note-taking app. It's an app that allows me to take notes. Oops, more spoilers. DevTools don't. They're closed. You haven't seen anything. This is a basic note-taking app. It allows you to create notes. You could type into notes. You could do, well, not much of stuff. But one more thing that this app supports is filtering notes. And the filtering notes section is actually pretty slow. So if you look at the spinner in the bottom left corner, this spinner spins when the page is idle and lags when the page stops spinning when the page is frozen. So if I try typing the F letter into the filter input right now, oops, hold on. If I try typing the F letter, am I typing? Oh yeah, sorry, wrong. I'm bad at this. Is this wrong keyboard? Oh yeah, perfect. Yeah, all right. So this is the right layout. So if I try typing the F letter now, you would see that the spinner freezes. I try removing the F letter, the spinner freezes again. I try typing a bunch of letters at once, and it gets really laggy. Like I try typing and it's slow. And like I'm pretty sure you've seen this at a bunch of sites in the internet. Now, whenever I have a performance issue like this, what I always do is I open DevTools and I try to reproduce this issue while recording it with the performance pane. So if I do that, I would click record, I would type the F letter, I would stop recording, and I would try to figure out what's happening here. So I would see a bunch of stuff. And by the way, like if you're new to the performance pane, like this might feel a bit overwhelming, but what we actually need to focus here on is just the CPU pane, which shows when the app is busy, and the main pane, which shows why the app is busy. And so what I'm going to do is I'm going to focus on this spike of CPU activity which indicates when the app was busy. And I'm going to try to figure out what happened in the app when I typed into the filter input. And so I see that I pressed the keyboard button, the key press event happened, that triggered the text input event, that triggered the input event, that triggered a bunch of functions, like dispatch script updates, which call discrete updates, which call discrete updates $1, etc., etc. All these functions come from React, which you could see by opening the summary pane and checking the source of these functions. Or, by the way, my favorite way to quickly recognize that when I'm profiling React apps is to look for a function called unstable run with priority, which is in React 16 and React 17, this is a function that's like, if you see this function, everything below it is a React render. They removed this function in React 18, so now you have to, like, if you're using React 18, you have to look for performance work of root. It's less catchy, more annoying, so you could look for them too. And so what I see here is I see a whole lot of React functions calling each other. And if I scroll past these React functions to the very bottom of the recording, once the color changes, and the color, by the way, it doesn't bear any like concrete meaning. It just different files, different functions from different files get different colors. So if I scroll past these colors, past this flame chart, I would see in the very bottom of the recording, I would finally see my components being called. Like I would see the nodes list component being rendered. And then next to it, I would see the node button component being rendered. And then I would see a React Markdown component being rendered, and another React Markdown being rendered. And more node button, more React Markdown, and like this through the whole recording. OK, so if I was to debug this a little bit more, what I would realize is what's happening in the app is I'm typing into the text field that calls the setFilter function, which is a useTake hook, which controls the state of the app. That changes the state in a bunch of components. And that causes React to render all these components one by one until it's done. And this re-render, it's a stop-the-world operation. Nothing can happen until React is done. If the user tries to interact with the app in any way, they'll have to wait until the re-render is done. And if rendering the app takes 2 seconds, the user will have to wait for 2 seconds. And this is how React 17 works, React 16 works, even React 18 works out of the box. It's a pretty standard, typical JavaScript blocking behavior. I'm not super familiar with other frameworks, but from what I know, out of the box, they work absolutely in the same way. Now, so let's take a step back. We have a performance issue. I'm typing into the text field. The text field causes the list of nodes to render, right? And this render is blocking and expensive, which slows the app and the whole typing process. And by the way, one thing I could do also to see what's actually rendering is to go to the components pane, which is the React DevTools thing. I could click View Settings, and I could click Record. Oh, no, sorry. I could click Highlight Updates when components render. And now if I type, I would see the components that are rendering being highlighted in green. It's like the Chrome's feature for panes, but for React. Like Chrome has similar thing for panes. So I'm typing into the text field, as you can see the list of nodes renders, this whole list of nodes. And this render is blocking and expensive, which is making the app slow. So my question to you, actually, how would you try to solve this if you were maybe not a React developer, if you were a developer with React 17? There are multiple solutions here. What would you try? Debounce, yes. Great solution, one of them. Any other ideas? How do you optimize a list of expensive renders, expensive components? Sorry, I can hear it? Request idle callback. Also, by the way, an option. Oh, I like that. I don't have that mentioned in the next slide. Great. Any other ideas? OK, so where's my mouse? Here's my mouse. So yeah, there are multiple ways, there are multiple things we can do here. We could wrap the components with React Memo, which would prevent them from rendering unnecessarily. We could optimize the component if maybe my node button component, maybe my node button component is expensive, And so if I make it cheaper, it would make the whole render faster. We can virtualize the list, which is some talks have been mentioned, by the way, yesterday, which makes, like, instead of rendering the whole list of 1,000 nodes, you would render just a list of 10 or 15 nodes, and that would be also cheaper. You could debounce or throttle. And so these are all great solutions, and you can even combine them. But what React does is it introduces another solution to the mix, which is making updates non-urgent. Let's see how this works. So with React 17 and below, every update that happens in the app is considered urgent. You click a button, and React has to handle that immediately. You type into the text field, and React has to handle that immediately, unless you were, I know, using unstable schedule APIs, which nobody does. Some people do. With React 18, however, your updates now can have a priority. And every update, by default, is urgent. But what React now also supports is non-urgent updates. And non-urgent updates, they don't block the page, no matter how long they take. Let's see how this works. So I'm going to switch to the code. And again, this is the React 17 app. I'm typing into the text, I'm typing into the filter, and the app freezes. You can see this because the spinner stops lagging. Now, I'm going to upgrade this app to React 18 by running some commands on my site, which you can't see. Secrets. Oops. Oh no, what happened? Oh yeah, right, here it is. So now this app is running React 18. As you can see, there's like the number 18. And now if I try typing, so nothing has changed in this app. Oh yeah, so nothing has changed in the app. Now, if I try typing into this filter input, by default, it would still block the app. It would still freeze the rendering. But what I can do now is I could take this update and I could mark it as non-urgent, and React would render this update differently, preventing it from blocking the page. So to make an update, how do you do this? So to make an update non-urgent, you need to use one of 3 new React 18 methods. You need to use useTransition, the start transition import, or the use deferred value. So they're all pretty similar, so I'm going to focus only on the one of them, useTransition. And let's see how this works. So what I'm going to do is for this to work, one critical change that I need to do. So here's the code for this node lists sidebar that you see on the right. In the code, there are 3 components that you can also see on the right. There's the filter input component, here it is. There's the nodes list component, it's the list of nodes. And there's the node controls component, which is this. And if you look at this code, what you might notice is that I have the single piece of state filter, which controls 2 components at the same time, the filter input component and the nodes list component. But what actually is important here is that one of these components, updating one of these components is an urgent action. I want to update the filter input as soon as possible, because when I'm typing into the filter input, I want it to display my text as soon as possible for the app to feel responsive. But now the nodes list component, it could update later. It doesn't need to be urgent. So what I'm going to do now to tell React that one component is urgent and another component is non-urgent is I'm going to take this state and I'm going to split it into 2 bits of state. OK, yeah. Let me do this. Yeah, this is going to be better. So I'm going to split this into 2 bits of state called filter input and filter value. Ooh, wow, look at that. I'm better typing. Filter input and filter value. And I'm also going to give them set filter input, set filter value. I'm going to make these states control different. So I'm going to pass these different states to different components. The filter input state would control the filter input component. The filter value state would be passed to the nodes list component. And now one more change I need to do is I need to, so every time I'm typing to the filter input, the onChange event happens, and I need to update both bits of state, right? Like this. And so what I've done right now is I've just took my single bit of state, and I split it into two identical bits of state, like two identical variables that hold the current filter value. And like right now, this doesn't really do anything. So if I try typing into the filter, I would still see that it's laggy. The spinner still lags. I'm still rendering 1,000 of nodes, and it's really slow. But now, what I'm going to do is I'm going to tell React that, look, this second bit of state is actually not urgent. You could take it and you could render it without blocking the page. And to do that, I'm going to wrap this bit of state with start transition, which is a function that I could take from the hook called useTransition. useTransition. Yep. And so what I've just done is I've wrapped my second filter, my second state update with useTransition. This would tell React that the state update is non-urgent. And now look at this list of nodes. I'm going to type into the editor, and the page is not going to freeze. Look, I'm typing to the editor. It renders, it filters the nodes, but the page now does not freeze anymore. Again, if I comment out start transition, I just keep my 2 bits of state. I'm typing to the editor, I'm typing the letter F, and the page freezes for a whole second because it needs to render all these nodes. And if I add start transition back, I would type into the filter, and the page would not freeze. It would render the whole list of nodes, but it would not block the page anymore. And it's so cool. It's almost like magic. Like I'm rendering the whole list of expensive components, and it doesn't block the page at all. So my question to you now is, could anyone guess how this works? This question to the room. How React does this non-blocking rendering of 1,000 expensive components? Yeah, go ahead. Yeah, pretty much. OK, well, so brown slide. The way this works is giving back control to the browser. So React starts rendering the app, and then gives back control to the browser after every frame. Let's see how this looks in DevTools. So I'm going to open DevTools, and I'm going to open the performance pane, and I'm going to record what's happening in the app when I'm bad at focusing. OK, yes. So I'm going to record what's happening in the app when I'm typing the filter input. And as you can see, I'm typing the filter inputs. The whole thing renders. But if I look into the recording, if I look what happens now, I would see that there's still a huge spike of CPU activity, which is yellow, which is a bunch of JavaScript. But now, and this is like, I have 2 spikes because I typed twice. But now, if I zoom into this spike and try to see how this works, I would see that in the very beginning of the spike, I have a single expensive blocking render, which happened when I pressed the keyboard button, which rendered my nodes list component and a few other components which are considered urgent. But then React finished the urgent render, and it gave the control back to the browser so that the browser could render the UI and show the update on the screen. And then, once it's done, React has scheduled the next update, which started rendering the next few components. Like it rendered the nodes list again, and it gave the control back to the browser. And then it rendered a few React Markdown components, and then gave the control to the browser again. And then it rendered the React Markdown and gave the control to the browser, et cetera, et cetera. And so this is pretty much what React calls concurrent rendering. Instead of rendering everything in one go, it gives the control back to the browser after every frame. But how is it implemented? So here's how concurrent rendering conceptually works under the hood. So React has a queue of updates. In our case, this queue has updates that don't need to be updated urgently. It's the nodes list component and a bunch of node button components. React also has a function called perform work until deadline. This function takes the update queue, and it processes this update queue one by one. So in React 17, this was pretty much it. You would start processing the queue, and you would keep processing the queue until you're done. And all this time, this thread would be blocked. But React 18 added two critical changes. First, in the while loop, it added a check called should yield to host, which tells React whether it should give the control back to the browser. And second, after the loop, React now checks whether there are still any pending unprocessed updates and schedules another perform work until deadline function to be executed in the next frame. Now, should yield to host, that function that checks when React should give the control back to the browser, is currently basically a one-liner. It runs through if the current render has been taken more than 5 milliseconds. That's pretty much it. More than 5 milliseconds has passed, OK, you should give the control back to the browser. The schedule perform work until deadline function, the function that schedules the next frame, it doesn't actually use request animation frame. It uses a different approach. So in an environment like Node.js or very old Internet Explorers, it calls setImmediate. In older browsers, it calls setTimeout with a 0 delay. This schedules a macro task to run in the next frame, to run after the browser has been able to render the results on the screen. And in modern browsers, it does this a bit of advanced trickery. So in old browsers, when you call setTimeout with a timeout of 0, what actually happens is browsers clamp that 0 to a value of 4 milliseconds or 1 millisecond. They don't allow you to schedule the work immediately. They require you to, they introduce a tiny bit of delay. So what React does to avoid that is it uses this message channel API, which it posts the message to, and then adds the callback that triggers when the message is posted. And it basically works in the same way with the setTimeout, except it doesn't have the clamping. It doesn't have the 4 millisecond minimal delay. By the way, this 4 millisecond minimum delay has been removed from Chrome recently, so it's not going to be useful in Chrome anymore. And yeah, that's how it's implemented. So if you remember the slide from the past, this is how React 17 behaved when I tried to type into the filter field. So I typed into the field that changed the state in a bunch of components, and React rendered all components in one single pass. Right. Now with React 18, this changes. When I try to type into the filter field, React calls two functions. It calls setFilterInput, and then immediately after that it calls setFilterValue, which are micro functions, I call them. And that causes the state to update in a bunch of components. But now, some of these updates are urgent, and some other of these updates are non-urgent. And so what React now does is it renders the urgent updates, still renders the urgent updates in the old blocking manner, no matter how long they take. But then, it takes the non-urgent updates and it starts rendering them in a non-blocking way, giving the control back to the browser every 5 milliseconds. And so now, if the user tries to click something during rendering, that click will be handled pretty much immediately, no matter when the click happens, because every non-urgent update would typically be blocking the main thread for only 5–10 milliseconds. And this is React 18's concurrent rendering, and this is how it works under the hood. Now, this is also a big big reason why I'm so excited for this release, because sooner or later, Google might make INP, interaction to next pane, to the next core vital. And right now, every React client I work with as a consultant has their INP way in red. So I'm hoping this might give tools to push them into green a bit. So that's how concurrent rendering works with useTransition hook. Now, there's also another case where it helps, and it's React hydration. And so if you're not familiar with React hydration, hydration is basically a process where you server render a site, then on the client, hydrate that site, render every component again, attach event listeners to the DOM that the server served you, and then you get a live site. And hydration, in my experience, is typically the most expensive JavaScript operation in any React app, simply because React has to render every component on the page. And it has to do that in one go. So just some examples. Like here's, for example, Deliveroo spending 1.55 seconds, a second and a half, hydrating the site with 4x CPU throttling. You visit the site on a phone, and the page gets frozen for 1.55 seconds. You can't track the page. Or here's Walmart spending 1.10 seconds. Or Notion spending 1.8 seconds. And I don't mean, to be clear, I don't mean to dunk on these websites or these teams. This is a standard situation. Every React site has this. This is what happens with React. Now, anyway, what React 18 allows you to do now is it allows you to take your site, like this Notion site, for example, figure out which parts of it are non-interactive or non-critical, and wrap these parts with the Suspense component, which is just the component exports. And so what this would do is this would apply the same approach to rendering that we just saw with useTransition. It would apply the same approach to rendering to the parts of the app wrapped with Suspense. So we would call hydrate root on the client when we are hydrating the app. And React will start rendering components one by one until it stumbles upon the Suspense component, which is called Suspense boundary in the React speak, which, as React will understand, it marks the non-urgent updates. So it won't proceed past that Suspense boundary just yet. It would remember where it stopped, and it would keep rendering urgent components until it's out of urgent components. And then it will yield the control back to the browser and will start rendering non-urgent ones, non-urgent components, giving the control back to the browser every 5 milliseconds. Here's how this looks in DevTools. So I have the second tab with the app that does hydration. And if I click reload and see what happens in the app when it hydrates, I would see pretty much the same picture we just saw with useTransition. I would see, so this component, this part of the app is wrapped with Suspense, as it very explicitly tells us. And if I try to find the moment when React starts hydrating the app, I would see the single semi-expensive hydration call, React hydrate root call, which hydrates the parts of the app that are not wrapped with Suspense, like this filter and not buttons and stuff. But then once React is done doing the expensive hydration, it would take the components wrapped with Suspense and it would start rendering them a few components at a time, just giving the control back to the browser every 5–10 milliseconds. And this helps with the INP too, by the way, because now you have, if you have an urgent hydration, so now you have an urgent hydration, an urgent part of the app, and a non-urgent part of the app. And if the user tries to interact with an urgent part of the app, like the product menu, the pause will be smaller because the urgent part of the app will be smaller. React would finish rendering the urgent update sooner. Instead of spending 1.5 seconds blocking the page, it would spend now 0.5 seconds blocking the page. And it will be able to handle that click faster. Now, you might ask, OK, but if this is so good, if this makes the page so responsive, why don't I wrap the whole app with Suspense? And does anyone have any idea why don't you want to wrap the whole app with Suspense? This requires you to be pretty familiar with React 18, but I'm curious if anyone knows. Yeah, you know. It doesn't, but that's actually a nice guess. Maybe, or maybe, like, I don't know. I haven't profiled it. I can't. Not sure right now. That's interesting. Any other guesses, or does anyone know?
Everything's under suspense. So
Yeah, why is it bad?
why is it bad? If everything's suspense, then nothing's in suspense?
Yeah, kinda, but not really. So yeah, so the answer is, if you wrap your whole site with suspenses or just the parts that are non-urgent, it would actually flop your INP. Why? Because, and this is a really interesting React specific. This is the part that I actually like in the React design. It's like you could try optimizing for the INP metric, but React team doesn't do that. It optimizes for the actual user experience because INP is just a proxy of user experience. So if you wrap a large part of the site or the whole site with suspense, yes, that part of the site would start rendering in this nice, non-blocking, responsive manner, giving back the control to the browser every 5 milliseconds. But then, the moment the user tries to interact with the app, interact with something inside suspense, like clicking this product menu, React would realize, OMG, the user tried clicking something in the app. And like if I keep rendering everything in the same manner, they would have to wait for, I don't know, a while until that click can actually happen. And also that click event would be lost because I'm giving the control back to the browser every frame. So what React does when the user clicks something inside the suspense boundary is it immediately switches back to the urgent rendering, and it renders the remaining part of suspense boundary immediately. Again, here's how this looks in DevTools. And this part is pre-recorded because it's pretty hard to reproduce. But in my first trace, this is the trace of when I reloaded the app, and then I tried clicking the suspense component at the very right moment. And if you look at what's happening here, you would see that React started welcome setup. Wow, that's like Windows XP function names. So if you look at what's happening in the trace, you would see that React started rendering this part of the app in a non-blocking manner, spending like 5, 10, maybe a bit longer sometimes, milliseconds at a time. But then once I clicked the page, once the pointer down event happened, React immediately switched to non-concurrent rendering, and it rendered the remaining part of the app in the blocking manner. And so what this means for INP is this basically means the moment you click the page, React switches back to React suspension rendering. So if you have your whole app wrapped with suspense, the moment you click the page, React would still block the page for the same amount of time it would have blocked it with React 17. So it doesn't help with INP at all. And yeah, so that's the second concurrent feature in React 18. It also helps to improve your INP unless you try to apply it too much. Now, what about drawbacks? Because, of course, there's no free lunch. So the first drawback is that non-urgent updates actually take a bit longer. React has to yield the control back to the browser all the time, and that introduces some delays. Like, let me show you. Here's again my React 18 app. So if I uncomment, or if I switch it back to React 17, which again, secret commands on my display, if I switch it back to React 17 and try to record with the performance pane how much time it takes. Oh yeah, right. It got broken because like it doesn't have start transition and use transition. Yep. So now it should work. So if I try typing right now and recording how much time the UI update would take, so I would type a single letter, and I would stop recording. And I would check how much this takes, and I would see that it takes like 1.07 seconds in this case, right? So it takes React to display the update 0.07 seconds. Now, if I switch back to React 18 and bring back start transition, and try to measure how much time it took now for the UI to update. So click record and press the F button and stop recording. So I would see this spike of CPU activity, and if I try to measure how much time it took, which by the way I could do by holding Shift and selecting the part of the recording, it took 0.6 seconds for the UI to finally update for React to finally show the results of the non-urgent render. And like, this is expected because it's a non-urgent render. It's like, or maybe it's probably okay because it's non-urgent render, but that's something you need to keep in mind. Non-urgent updates typically take a bit longer. And now this would hopefully maybe be solved with a different should ill to host implementation, which is should ill to host is the function that tells React when it should give the control back to the browser, right? So this may be solved with a different should ill to host implementation, which is currently implemented behind the flag. So today, as we talked, should ill to host is basically a one-liner. React gives the control back to the browser every 5 milliseconds. Now, the implementation that's currently behind the flag is more sophisticated. Specifically, instead of just yielding back to the browser every 5 milliseconds, this implementation uses the isInput pending API, which Katie has been mentioning yesterday, to check whether the user has tried interacting with the app. And it yields back to the browser only if the user did interact with the app, or only if the render took more than 300 milliseconds. So yeah, it relies on the navigator scheduling isInput pending API, which is currently Chromium only. And also, I'm not really putting high hopes on this thing going behind out of the flag, behind what's the right thing? Being released. Because as Andrew Clark from the React team clarified tonight, they actually ran perf experiments on this implementation, and it was unconclusive. So yeah. The second drawback is this whole extra complexity, it doesn't come for free. So to make concurrent rendering possible, React has to make the architecture much more complex. It introduced React Fiber, it introduced concurrent rendering checks on the runtime. All this stuff takes a toll on the CPU. And in fact, this is one of the reasons Vue and Preact straight refused to implement anything similar to concurrent rendering. Both Vue and Preact believe that it's unlikely that any real-world apps will benefit from concurrent features. Like, here's Marvin from Preact saying, it's still up in the air whether concurrent mode is something that benefits apps at all, even for React. Or Evan Yu from Vue saying, the concurrent demo that React team showcased is so contrived that it will most likely never happen in an actual app. And to be clear, I'm showing screenshots from 2019 and 2020, but the position hasn't changed. Based on the Twitter conversations, based on the GitHub conversation, nothing has changed even since. Now, the React team, however, seems to play a long game and is explicit about it. Mostly in Twitter, though, because that's where the real documentation lives nowadays. For example, one of the things the concurrent features will unlock is the upcoming off-screen API. It's like a link rel pre-render, but for UI parts. The off-screen API will allow to pre-render stuff like inactive fruits, tabs, etc., basically anything in the background, so that when you click a link or click a button or switch between tabs or anything, the switch happens literally instantly. React would just hide the current visible DOM node, and it would show the DOM node it was rendering in the background. So the off-screen API pre-renders inactive parts of the app in the background, and it does it in the same non-blocking way useTransition and Suspense do it. By the way, thinking about this right now, Chrome actually tried to implement something like this a while ago, and then they rolled it down because it was too CPU expensive, right? So like link rel preload was, Paul is looking at me right now, so he probably has some, anyway. Well, and what do I think about this disagreement between React and Vue? Well, so there's also a third drawback / pitfall. React concurrency doesn't help to optimize expensive components. If you look at React's primary rendering loop again, you'll notice that the should-to-yield-to-host function, the function that checks when React needs to give the control back to the browser, the should-to-yield-to-host function, it's only called after every render. So the perform unit of work function takes one component from the queue and renders it. And after that, React checks whether it should return the control back to the browser. So if any single component takes, for example, not 5, but 500 milliseconds to render, the main thread will still be blocked for the full 500 milliseconds. And that's because React has no way to interrupt rendering of a single component. Rendering a single component is just literally calling that component's function, or calling the render method if you're using class components. You can't stop the function after you've started executing it, unless you close the tab. React is too slow for React. Close the tab. And this is the third drawback of React concurrency. So to summarize, React concurrency is slower for non-urgent updates, more CPU expensive for all updates. It also doesn't help with expensive components, which is more of a pitfall, not a drawback. But if you're willing to deal with these drawbacks and pitfalls, you would get this almost magical behavior of rendering something huge, rendering a huge part of the app, and not slowing the page at all. Is this a meme? Maybe this is a meme. Thank you. I'll tweet the slides right after this talk. I still need to tune them a bit, so you'll find the slides on Twitter, and you might also want to follow me. No pressure, though. Thank you.
No pressure, no pressure. Come on, Ivan, step into my office right here. I mean, this is kind of awesome. It's like, what do we call it? Hall of Same. You know, we're both in black. Like,
oh, yeah.
It's very serious right now. It's like the clergy.
Shall we play some techno?
No.
OK.
Just played. Thank you very much for that.
Thank you.
I think you sort of asked already, but I kind of want to get a good shot of it. Hands up if you do not use React. OK. What would you tell this audience right now in terms of just like convincing them to use React as a performant platform?
I won't.
OK. What he's saying is you're not invited to the party. Oh, I'm just playing.
Is there a React party?
I mean,
do they suspense?
You know, apparently they don't like techno.
Oh, like, I'm not going there.
All good. Let's get into some questions that came here. Let's start with this one. When using Suspense, wrapping the entire app's content, and the user clicks the Suspense wrapped content before async rendering is complete, why does React have to switch to traditional sync rendering? Can't the click be processed in the async queue? So
I think they actually tried doing this while working on their React 18 release. So if you tried using the early React 18 alphas, what React tried to implement is the event replay. So like React has this whole custom synthetic React event system, right? So it could do a bunch of trickery with events. And so what React was trying to do is it was recording the event that like you click something, React was recording that event. I think it was continuing, so like don't quote me on that, I might misremember that, but I think it was continuing to render everything in the known urgent way. And then once the render was complete, it would replay that event and replay the click, and so the component would handle that. They had to roll it back for some reason. I think they found some edge cases which weren't being replayable well. So they kind of had to roll it back to the current implementation. But also, I kind of like the current implementation more, because if you click something, you want to click the happen as soon as possible. And non-urgent updates, they do take longer, as we just saw. So you do want that click to be handled as soon as possible, even if it means like the page needs to freeze for a bit. All right.
Thank you for that question, by the way.
That's a great question.
And another one just came in. Why not code split and lazy load if you why not code split and lazy load if you are going to use Suspense?
I mean, why not? You can.
OK.
I mean, they interact. Yeah, they interact in some. So like if you try code splitting and using React lazy and putting that component into the Suspense boundary, It might, like I don't really remember, it might render you a fallback instead of, so the Suspense fallback instead of the the UI. And sorry, if you're not using React, sorry, there's a lot of React speak. But I don't really remember that. And like, yeah, it does interact in a complex way, which I don't remember, and React gets too complex at times. But you totally can code split and lazy load.
All right. Quick question. What did you think about some of the announcements this week coming out of San Francisco over at Next?
Oh, well, I thought that I was very annoyed that the conference was happening on October 25th, and I had a ticket for October 22nd from San Francisco to Amsterdam.
Okay, so basically you would have been there.
Well, if I got admitted, it was the very private club invitation only.
Yeah. Okay. I mean, the last questions here is cute and innocent. What tool are you using for your talk, for your slides?
It's PowerPoint.
Okay, there we go. Thank you very much.
Thank you. Thank you for an amazing hosting.